Hello, my name is Erdem Topsakal. I'm the editor-in-chief of IEEE Antennas and Propagation Society, Digital Communications. Today, we are here with one of the movers and shakers in our society, Professor Danilo Erricolo. Welcome.
Thank you very much, Professor Topsakal. I appreciate the opportunity for this interview.
Thank you so much. I would like to start with a little bit for the audience to get to know you, about your background. So how did it all start? How did you get into engineering? A little bit, if you can give us some information about your background and how did you get into academia?
Well, thank you for the question. So there are a few factors that determine my choice to pursue electrical engineering. The first one, or at least the primary one, is the fact that I've always been curious about how system works, how things work. So, for example, when I was a little kid, I would break all my toys to figure out what was inside, especially when they had moving parts. That caused me a lot of troubles with my parents. So I had to stop breaking toys, but I still maintained the interest in understanding how things work. And then later on, going to school, I developed a fascination and attraction towards mathematics, the sciences, and physics. And in high school, I was very interested in computer science, still the old theme of figuring out how things work. And when it came to deciding which university degree to pursue, I also added another element in my decision, which was what type of job do you end up doing once you graduate. And among all the choices, I felt engineering was the best because in engineering, you definitely have plenty of opportunities of using mathematics, physics, studying sciences. It's the best degree to figure out how systems work. And it's a solid degree. Engineers will always be needed. And in particular, electrical engineering gave me an opportunity to further develop my curiosity in computers and how they're built and how they're operated. And so I studied at the Politecnico di Milano. I pursued a completed thesis in solid-state electronics. And then at that time, there was a conscription for men that, were of Italian origin. And so I ended up serving about a year and 3 months in the Italian army as one of the members of the Corps of Engineers. During that time, I decided I wanted to pursue a Ph.D. in the United States. So after I completed the service, I went to Chicago, to University of Illinois. At that time, it was called University of Illinois at Chicago. And I pursued a Ph.D. in electrical engineering and computer science. And I studied for my dissertation, a method to compute the propagation of the electromagnetic field in a complex urban environment. And the application of that study is for wireless communication systems, where if one needs to deploy a wireless network, one of the challenges is to determine the best location of the antennas to guarantee field coverage. And so with those methods, one can figure out the coverage that each antenna produces so that you can eventually determine the overall coverage and optimal locations. And then after that, I decided that initially I always wanted to go and work for the industry, but then I somehow became so fascinated with what I was doing, and there was an opportunity to continue as a postdoc, and so I stayed at UIC, and then I became a research scientist, and then since 2004, I have been a member of the faculty. I received my tenure in 2007. 2010 became full professor. And I've done a lot of things for the university, including 4.5 years as director of graduate studies, and now, in addition to my research in electromagnetics and being the director of the Andrew Electromagnetics Laboratory, I also am the director of international programs for our College of Engineering.
I guess the rest is history, you would say, once you started the academic career. So as we all know, academic career requires, there are different pillars: research, education, and service. And you have done quite a bit of service. But I would like to first ask about the research part of it. As a new faculty member, what kinds of areas you started with early in your career, and then how is it going right now? Or the new areas. How has your research been throughout the years?
So initially, I started in a way that I think is similar to most, meaning I found a research project that was the natural outgrowth of my Ph.D. dissertation. So I worked on a NSF grant about developing a test bed for measuring the performance of models and the accuracy of models for the propagation of the electromagnetic field. Then I had an incredible opportunity because in 2001 I became part of a MURI team, a multi-university research initiative program supported by the US Air Force Research Laboratory to study the propagation of high-power ultra-wideband pulses inside a complex digital system. That gave me the opportunity to work with the best of the best in the field of electromagnetics in the country. And so I started developing a lot of more personal connections with a lot of these big names. And that was very important for me to learn other things beyond the strict, scientific knowledge. After that, I had the opportunity to work on a second MURI project that combined the field of signal processing with electromagnetics, because those were research activities focused primarily on the application of radars and also communication system in a complicated environment. It was a study focused on essentially waveform design to optimize the waveforms once you know the environment where this waveform are used. That was a very interesting project because it connects with one of my current research activity, which is the smart electromagnetic environment. So I learned about the smart electromagnetic environment during my 6 years of service as editor-in-chief of the Transactions on Antennas and Propagation. And it's, I think, the smart electromagnetic environment, I think, is a new approach that is, it has the potential to be significantly transformative for communications, because the idea is to take actions so that the environment between the transmitter and the receiver can be controlled by humans. So if you think about the evolution of communication systems from Marconi's radio, we've always tried to improve the antenna, for example. Well, not necessarily just the antenna, but let's say the transmitter or the receiver. One of the things one can work on, of course, is the antenna or maybe the signal processing or the hardware. But fundamentally, whatever is contained within the definition of transmitter or receiver, those are the things we normally affect with our research and studies. But what is fundamentally new with the smart electromagnetic environment is that if you have a situation where, for example, you don't have a line of sight between transmitter and receiver, you could take advantage of these new, let's call them entities, the reflective intelligent surfaces or smart surfaces, there are various names to address them. They can be explained as essentially a surface made of smaller tiles where each one of the individual tiles can be ideally controlled so that the electromagnetic field that is incident on the tile can whatever is reflected by the tile, that field can be controlled in amplitude and phase. And if you can do that for each individual tile, then there are very interesting phenomena because the surface as a whole could, for example, reflect along direction that are not what you would expect by the normal laws of reflection, but it's just because it's the cumulative effect. And as a result, you could, using one of these surfaces, you could imagine coating one of the facade of a building and create a reflection that points exactly where you want your electromagnetic wave to go and things like that. You can also use them in an indoor environment. And there are solutions which are very sophisticated, but there's also solutions that are very simple that improve upon what we can do right now. So that's one of my current research activities. I've also worked on magnetic resonance imaging because in 2005, UIC had the first research center where one could find a experimental 9.4 Tesla MRI scanner. That was an MRI scanner where you could put like a person, so not a smaller one. I found always MRI a very fascinating field, and what people have tried to do over the years is to increase the strength of the static magnetic field, the B0 field, because that increase in improves the signal to noise ratio. But as it is the case many times, there's no free lunch. So it's not because you just increase the static magnetic field, all of a sudden everything else is automatically taken care of. You have to deal with the fact that the Larmor frequency increases, therefore the wavelength decreases, and now the wavelengths are sufficiently short that within the human body you can see more than one wavelength, and so you have the field, the radio frequency field within the body that could show maxima and minima. So problems of hot spot and cold spot, which is similar to what you have in a microwave oven when you cook something and a portion of, let's say, a piece of meat is hot and the other is cold. And so we worked on antennas and methods to control antennas so that you avoid, for example, depositing too much energy, which would result in burning the patient. Another field of research is one that impacts civil engineering. Around the world, there are plenty of bridges, and these bridges, especially in areas like Chicago, where we have very harsh winters. So the Department of Transportation is forced to use enormous quantity of salt to keep the surfaces not slippery. That salt causes damage to concrete, and eventually that concrete develops cracks and water penetrates into it, and the steel becomes rusty, and then there is a nasty sequence of problems. And so in order to monitor the structural health of a bridge, we are working on a ground-penetrating radar system that is installed on a flying drone and is used to essentially inspect bridges and provide indications that are meant to observe if there is any issue with, the understanding that the whole point is to do maintenance as early as possible rather than waiting when it's obvious that the bridge is about to fall because you can't see, pieces of concrete simply detaching from the bridge. My fourth area of research is about wireless communications, the future generation wireless communication. I have an interest in in-band full duplex systems, which are supposed to be used in future generations of wireless communication. And they are important from the point of view of improving the spectral efficiency by allowing to simultaneously use the same frequency band for both upload and download of the signal. Of course, like the other example, there's no free lunch ever, but that's why we are researchers, and we always need to figure out how to use the laws of nature in our favor. So those are my primary areas of research, and also sometimes do more classical electromagnetic scattering studies from canonical shape, but that's more of a hobby that I play with when I have time.
Well, great and exciting research areas indeed. IEEE, my next question is about IEEE Antennas and Propagation Society. The society has been a big impact, played a big role in my own career. And I know that it has played an important role in your career as well. Can you tell us a little bit about your first interaction with the society, and then conferences, memberships, and all that? And I know that you have served on different assignments throughout the years. Can you tell us a little bit about the society and your involvement?
Yes, it started. The very first time I interacted with the society was with the very first conference in 1998 in Atlanta, when the general chair was Andy Peterson. And then I attended a few times. In 2005, Bob Nevels came to me and said, Danilo, we were thinking about asking you to organize a conference in Chicago in 2012. I thought it was a little early, 7 years before the event, but I accepted the challenge. The conference was very successful. That gave me an opportunity to interact with a lot of members at a deeper level than just what happens when, let's say, you participate in the conference during the yearly summer event, but then the interaction stops there. And then immediately afterwards, in 2012, I became an elected member of ADCOM, and I served as an ADCOM member for 3 years, and during those 3 years, I contributed to the creation of 2 new journals. That was a very interesting experience because you see how you actually do things. You see a complete different side. I've also served as chair of the joint chapter between APS and Microtheoretic in Chicago, which gave me another opportunity to serve on behalf of the society at the local level and organize workshops and seminars and things like that. And in 2015, I also became chair of Distinguished Lecturer Program, which gave me an opportunity to interact with all the chapters around the world. And we came up with this interesting idea of using Google Maps to provide a visual representation of where the chapters are and where the distinguished lecturer goes, so that it made it very easy for the chapters actually to know, there's a there's a deal in a nearby channel, why don't we send him or her an invitation? Then between 2016 and 2022, I served as editor-in-chief of the Transactions, Antennas and Propagation, which is a very demanding job, about 20 hours of work per week. Every day we would receive something like 10 submissions, and so there's always something to do for the journal. When I stepped down, because I completed my 2 terms, I have become chair of the meetings committee. So now I deal with conferences not as directly a conference organizer, but as the chair of the committee within the society that coordinates all these conferences. So it's a very, again, interesting experience, and we're trying our best to provide very good events on behalf of all the members of the society.
Great, great. Well, last but not least, we want some words of wisdom from you. So we have many students, audience, young professionals just starting. So what would be your advice, for incoming PhD students, those about to graduate, PhD and cannot decide academia versus, industry and all that, and they're involved in APS and networking and whatnot. What would be your advice to, all the young generation out there?
Well, my advice is similar to what I was told, because I think it's still valid. One important consideration is try to do something you like. If you have a job that you don't like, it becomes very difficult. The ideal situation is when you have a job that is your hobby. So it pays you at the end of the month, but it don't feel like, it's a job. The field of electromagnetics in particular is very important because it's what I would call an enabling field, meaning without electromagnetics, I would say, if we were to remove from all the technological tools that we use, anything that depends on electromagnetics, we would not have any communication system, any smartwatches, computers, you name it. I would say the most advanced piece of technology would be probably the steam engine. We would be like behind of almost 200 years. So I cannot overemphasize the importance of electromagnetics. We are witnessing a world that, from the point of view of technology, is becoming progressively more and more complex. Electromagnetics gives us some sanity, in the sense that because it's so tied to the fundamentals of physics, it forces you to develop a skill that creates a bridge or a connection between the fundamental laws and how they can be applied. And so if you can study, my advice is focus on understanding the fundamentals and try to pick another topic. Maybe it's a secondary topic, like a minor topic in addition to electromagnetics. Maybe focus on how you can apply electromagnetics to improve a communication system or an imaging system or signal processing or remote sensing. And that will, I think, be an important skill, because people with a strong expertise in electromagnetics not only have to deal with a similar training, but it's very important to be able to communicate on a technical level, at least, with others. And I think if one can essentially position him or herself in a way that they can do more than just talking with the choir, so to say, that would, I think, make their degree more valuable. And then for the choice between academia versus industry, I think, I mean, I've never worked for the industry, but at least in the academic world, what I can say is one advantage is that you should be a little bit more in control of your time. You have the opportunity
That comes with responsibility, though.
Exactly. But you develop, especially if you are involved with the society. In fact, that's one of the benefits of the society, which I did not mention explicitly, but I did mention that you interact with people literally all around the planet. And you feel like you have this extended family of colleagues and friends. And I think I cannot name a country where I could go without probably already knowing someone because of the interactions that I had directly or indirectly through the Antennas and Propagation Society.
Thank you, Danilo. This wraps up our interview with Professor Danilo Erricolo. Please follow us on LinkedIn and watch all the videos we are creating for you. Until next time, stay happy, stay healthy.